Newtonian kinetics also applies to rigid bodies. So we remember for a particle, then we had some of the forces in the x direction, some of the forces in the y direction equals ma. And so this covered translation. Now for rigid bodies, we get these two equations, plus since a rigid body can rotate, we get a third equation. The sum of the torques equals moment of inertia times angular acceleration. This is the rotational component. So for rigid bodies, you still have to sum forces in x and y, but then you also get to do sum of the torques. And again, sum of the torques, it can be done around the mass center or a fixed point. So in a purely translational system, then we'll have sum of the forces in the x equals m ax equals m x double dot. Sum of the forces in the y equals m ay equals m y double dot. And sum of the torques equals 0. So torque around axis of rotation. And sum of the torques around the mass center equals 0. That is for pure translation. Because if something is only translating, then it's not rotating, so we know sum of the torques is 0. Now for fixed axis rotation, we've got, this is in polar, sum of the forces in the r direction equals m-a-r equals m-r omega squared. Sum of the forces in the theta direction equals m-a theta equals m-r alpha. And sum of the moments equals I alpha. So around axis, or you can do sum of the moments around the center of mass equals moment of inertia around center of mass times angular acceleration. So always sum moments around fixed axis of rotation or mass center of the object. So very, very important.